Hey guys, welcome to lesson 716, day 2. Yesterday, since we built the unit circle, today we are going to focus on how to use that built unit circle. We've spent a lot of time this chapter doing a lot of the behind the scenes work and seeing where things come from. But now that we have the unit circle, we'll be able to see how we can use it to pretty quickly solve different types of problems that used to take us a much longer time. So when we are doing problems like this that involve the unit circle and the coordinates particularly of the unit circle, it's important to remember two things. And that is that these coordinates, which are the xy coordinates, oh, that's kind of a fat pen, not doing it for me. All right, we have the xy coordinates. Those for us here become cosine and sine coordinates. You guys need to remember that the left number in the parentheses is the cosine and the right number is the sine. Okay, and in addition to that, you've got to also remember that cosine, that's ugly, nope, cosine represents the horizontal distance, goodness. Alright, this means horizontal distance. I'm just not going to win here. And then sine, sine is referring to height. We should know this by now. I'm just not going to start re-recording this just because my voice got janky, so sorry if you're watching this. Alright. So now that we have covered these two really important pieces of information, make sure you have memorized them as you go into these problems, because this is like what it revolves around. All right, so now let's say I'm asking for the height of a car on the unit circle, or the Screamer ride, and it's at 120-degree angle of rotation. So I am essentially right over here. All right. I'm looking at all the information that's relevant to the 120-degree angle. If they are asking for the height, that means I want the sine. Okay, look up here. Where it's height, it goes with sine. So the right side number in the coordinates is the one that I want to focus on here. Okay, and that's literally my answer. All I have to remember is that the number on the right is the height. Use that rhyme to remember it. Okay, the right is the height. The left side is the horizontal distance, which we don't care about in this particular problem. All right, so for my next problem, what's the horizontal distance of the car at 225 degrees? So let's find 225 degrees. It's down here, circling all the information that's relevant to it. And they want the horizontal distance of that car. So at that point, what we're going to do is look at the coordinates and remember that cosine is horizontal distance, sine is height, cosine is left, sine is right. So my cosine is going to be this number on the left side of my coordinates. So my answer here is going to be negative square root of 2 over 2. All right. So it's, as you can see, very important to keep straight when you need the left number and when you need the right. But like I said, right is height. Just remember that statement. All right, and one more over here, number 3. What is the height of the car in the unit circle if the horizontal distance is 1/2? Okay, so it's a kind of a differently formed problem, okay, but it still involves just us staring at the unit circle. So let's take a look at what we're supposed to do. So we want the height where the horizontal distance is 1/2. Now remember, horizontal distance is the left side in the parentheses. So if they say where the horizontal distance is 1/2, I'm going to look for all of the points of this format. I don't care what's on this side right now. What I need to know is where are the points that have a 1/2 in this spot. So as I look at my circle, this one doesn't cut it, this one doesn't cut it, oh, but this one does, right? So this one is important. And you can go all around the circle. Nope, nope, this one's negative. It was close, but it's negative, not going to cut it. Nope, 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 nope. Negative, not going to cut it. Oh, but look, we got another positive 1/2, and that is what we wanted. All right, nope, and nope. So now that I found my two options, let's go back to the question. It wants to know what the height is. Okay, so they told us the horizontal distance, and the height is going to be that second number there, the one on the right. Now, obviously, there are two options here. Either we can have positive root 3 over 2 if we're up here at the 60, or we can have negative root 3 over 2 if we're down here at the 300. I want to write both answers. All right, so either positive root 3 over 2 or negative root 3 over 2. Okay, both are valid. Sometimes I'll ask you for one, and in that case, I wouldn't care which one you gave me. And sometimes I'll ask for both, so then you got to give me both. At any given point, there's always going to be two spots that are going to have the same horizontal distance because of the symmetry. Similarly, there's always going to be two spots that have the same height as well. Okay, there's always pairs. All right, number 4, what is the height and horizontal distance of the car at 300 degrees? All right. Well, let's first erase this. Height and horizontal distance, that means they want everything inside of the coordinate, right? Both of these things. So let's just simply find 300. And I'm spotting it right over here. Okay, so my height and horizontal distance are these two little numbers. You just have to make sure that you pick the right ones. So my height is going to be the right side number. I'm telling you, right is height. So negative root 3 over 2. And my horizontal distance is my left number. So my horizontal distance is 1/2. All right, that's all for that one. Number 5, what is the height and horizontal distance, again, of the car that's at 7 pi over 6 radians? So no big deal, we just gave you radians instead of degrees. You can still find it on the unit circle. Let's delete this first. 7 pi over 6 radians. So you look around, these are all the radian measures, and you eventually come across this one right here. That's our 7 pi over 6. Let's go ahead and circle that. Now they want the height and horizontal distance, just like the last one did. So my height is on the right, so that's going to be this one. So it's going to be negative 1/2. And then my horizontal distance has to be the other number, the negative root 3 over 2, because that one is on the left, and horizontal distance is always on the left. All right, and that's all for that question. Number 6, if the sine of theta is negative root 2 over 2, what are the possible angles of rotation? And we want radian answers. So let's pay attention to what they told us. The sine of some theta, that just means an angle, is negative root 2 over 2. So the format that they want is where something is over here. We don't care, that's the cosine. But then on the right side, there's a negative root 2 over 2. So let's go ahead and search our unit circle for all the points that look like this. And right as soon as I erase this part. All right, so where can I find a sine that is negative root 2 over 2? You can start at the beginning if you want. Nope, this one's positive. Nope, 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 positive. Nope, nope, nope. This one works. That's a negative root 2 over 2 in the y spot. And then keep going, nope, nope, and this one also works. Typically, there are 2 answers for these kinds of questions. All right, so that tells me that at 7 pi over 4 and at 5 pi over 4, that is where I fit the criteria of the question. So I will write 5 pi over 4 and 7 pi over 4. Okay. I guess I can circle this. All right, one final problem. If the cosine of theta is negative root 3 over 2, what are possible angles? Now this time they want degrees. So now, before we had this format. Now our new format, they gave us the cosine, so we got to put it here on the left. Something on the right, we don't care. So we got to find all the points that look like this, that have negative root 3 over 2 on the left of the parentheses. So, I'm erasing all of this. Who has negative root 3 over 2 on the left? We can, again, start at the beginning. Why not? This one won't cut it because it's not negative, so we got to keep going. Nope, 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 nope. Oh, this one works. This has a negative root 3 over 2 on the left. Let's circle it. Keep going. Nope. Oh, this one has a negative root 3 over 2 on the left. And, of course, there really are only 2 options, but just to be safe, you're welcome to keep checking. You'll notice that none of these other ones have a negative root 3 over 2 on the left side. So our answers are going to be 150 and 210. And I'm saying that because they don't have pi's because this one is specifically asking for degree answers. All right. And that is the end of that. So that's pretty much how you use your unit circle to solve certain types of problems. There's one other thing I'd like to point out here. And that is that on MyOpenMath, on today's practice problems, those are right over here. I just do want to say that sometimes you will use your unit circle just like I showed you in this video. This is one of those types of problems. You find 4 pi over 3 on your circle, and you locate the sign of it. So for that problem, it would have been right over here. Negative root 3 over 2 would have been my answer, right? As you can see. However, as you go to another problem, this one is the same way, but as you go over here, notice how I put decimal use calculator in this directions. If I tell you that I'm okay with a decimal answer, that's when you have to give me a decimal answer, and that's when you don't use your circle. Instead, you can simply bust out your calculator, and if it says height, height is an indicator of sign, as hopefully you guys know by now. I can't say it enough. Make sure your calculator is in degree mode, should say degree up here, and I'll just take the sign of 330, and my answer is negative 0.5, and as you can see, that's my answer here. Okay, so if I am asking for a decimal, all you have to do is take the sine and cosine in your calculator. But if I'm asking for exact, like I was here, you have to use your unit circle to get that fraction answer. And yeah, this is also a unit circle question. Where is the sign negative 1/2? What are the coordinates? Okay, it already gave you half of the answer. So just to give you a little heads up for when you're actually working through the practice problems. All right. Good luck. That is all I have for you in this video. You know, like and subscribe to my channel. Okay, bye.